Right now, as you lie in the dark, moments are arriving. This one, now this one. Each new second feels like it is being made fresh, just for you. And modern physics has spent a century insisting that feeling is a lie. According to the equations, your future already exists. Every choice you will ever make is already sitting there, fixed in a frozen block of space and time, as real as a city you simply have not visited yet. Einstein himself comforted a grieving family with exactly that thought. But one physicist, a man who never finished high school, whose impossible experiment now sits in the textbooks, says we have been reading the equations backwards. He points to a bomb certified by an explosion that never happened, to a particle that briefly weighed less than nothing, and to laboratory evidence that the future is not written, because it does not exist at all. Not yet. By the end of tonight, you will know exactly what the most optimistic theory in modern physics claims, and why it may hand you back your tomorrow. Before we begin, if questions like this are how you like to drift off, a quick like or subscribe truly helps the channel grow. It is a small thing for you, and it means the world to me. Now, let's begin. The saddest letter in the history of physics was written in the spring of 1955, and it was meant as a comfort. In Princeton, New Jersey, an old man sat at his desk with a letter in front of him, and the letter carried the worst kind of news. Michele Besso was dead. Besso had been Albert Einstein's closest friend for more than 50 years, the companion of his youth in Bern, the colleague who walked home with him from the patent office while the theory of special relativity was taking shape, the only person Einstein thanked by name in the 1905 paper that changed physics forever. And now Besso's family was grieving, and Einstein, who had perhaps a few weeks left to live himself, picked up his pen to console them. What he wrote has been quoted ever since, and it deserves to be heard slowly. Michele, he wrote, has preceded me a little in leaving this strange world. That signifies nothing. For us believing physicists, the distinction between past, present, and future is only an illusion, however persistent. Consider what that sentence is actually claiming. Einstein was not offering a poetic image to soften a hard moment. He was stating, plainly and sincerely, what he believed his own physics had proven. Your father is not gone, he was telling Besso's children, because nobody ever goes. The young Besso, the middle-aged Besso, the old Besso, all of them are still there, fixed in their places along the fourth dimension, as permanent as cities on a map. Nothing has been lost, because nothing ever moves. The past has not ceased to exist, and, here is the part that matters for our story tonight, the future already exists in exactly the same way. Death is not an ending in this picture, but it is something almost stranger. It is a boundary line drawn on a finished object, like the edge of a page. Physicists call this picture the block universe, and we have walked through its foundations before on this channel. So tonight, we only need to stand at the edge of it and remember its shape. Take the 3 dimensions of space, add time as a fourth, and treat the whole 4-dimensional structure as a single, existing thing. Every event that has ever happened, and every event that ever will happen, sits inside the block at its own coordinates. Your birth is in there. This night, with you listening in the dark, is in there. And every day that you think of as not yet decided, tomorrow morning, next winter, the last day of your life, is in there too. Just as real, just as finished, just as fixed as yesterday. In the block universe, the future does not approach you. You do not create it. You simply encounter it, the way a train encounters stations that were built long before the train ever left. Most people, hearing this for the first time, assume it must be a fringe position, some philosopher's game, far from real science. The uncomfortable truth runs the other way. The block universe is the mainstream reading of relativity, and it has been for over a century. Ask a working physicist whether the flow of time appears anywhere in the fundamental equations, and the honest answer is no. The equations describe a four-dimensional geometry. They do not describe a moving spotlight of now sweeping along it. Nothing in the mathematics flows, passes, becomes, or happens. The world, in the equations, simply is. And yet everything you have ever experienced says otherwise. You did not experience this morning as a fixed coordinate. You experienced it arriving, being lived, and slipping away. You are experiencing this very sentence as something coming into being, word by word. The single most universal fact of human life, more universal than language, more universal than culture, is the feeling that time passes, that the past is closed, that the present is happening, and that the future is open. Every plan you have ever made, every regret you have ever carried, every hope you are holding right now for the days ahead, rests on that feeling. And the official position of modern physics is that the feeling is wrong. Not slightly wrong, wrong all the way down, a persistent trick played on every mind that has ever existed, from the first human being to you, tonight, in your bed. Tonight, I want to take you through what may be the most remarkable answer ever offered to that trick, a proposal that stands almost alone in modern physics, because instead of explaining your experience away, it takes your experience as the deepest clue we have. It comes from a physicist with one of the strangest resumes in science, and one of the most respected experimental track records in the foundations of quantum mechanics. And it makes a claim so large that, if it is right, nearly every popular science book on time will need a new final chapter. The claim is this: time really does pass. The now is real. The future does not exist, not as fixed events, not as empty waiting space, not as anything at all. And the universe you fall asleep in tonight is not a finished block. It is a construction site, and the leading edge of the construction is this moment. By the end of tonight, you will know exactly what this theory says, what laboratory evidence its authors point to, and why I have called it the most optimistic theory in modern physics. But the reason it is optimistic will only make full sense once you have felt the weight of what it is up against. So we have to begin where the trouble begins, with the fact that Einstein's frozen universe is not a careless idea. It is one of the best argued ideas in the history of science, and dismantling it will take everything the rest of tonight can give. Return, for a moment, to that desk in Princeton, because the scene rewards a slower look. It is late March of 1955. The afternoon light comes through the window of a study on Mercer Street, and an old man with famous white hair reads a letter that tells him the friend of his youth is gone. He is 76 years old, and his own heart is failing, and he knows it. He reaches for paper. He does not write, "I am heartbroken," though he surely is. He does not write, "We will meet again," because he does not believe it. He writes, instead, the most honest thing he has, that physics itself says the distinction between past, present, and future is an illusion. His pen moves steadily. He is consoling a grieving family with geometry. Somewhere behind the words you can feel the strange double life of the man, the human being who has just lost his oldest friend, and the physicist who believes that loss itself is a kind of misunderstanding, because in the four-dimensional block, nothing is ever lost, and nothing is ever gained, and the two friends walking home from the patent office in 1904 are still there, still walking, forever. 3 weeks later, Einstein himself was gone, or, as his own theory would insist, he simply reached the far edge of his world line, which had been sitting in the block, complete, all along. Here is what makes that letter an emotional hinge for everything that follows tonight. Einstein meant it kindly, and there is a real consolation in it, the past preserved, nothing truly erased. Many people find peace in that thought, and nothing tonight is meant to take that peace away. But notice what the consolation costs. If nothing is ever lost, then nothing is ever made. If your father's childhood is safely fixed in the block, then so is every choice he ever agonized over, fixed before he agonized, fixed before he was born, and so is every choice you have not yet faced. The same geometry that comforts the grieving quietly informs the living that their deliberations are a formality, that the wedding and the diagnosis and the reconciliation and the last goodbye are already in place, waiting at their coordinates. A universe that loses nothing is also a universe that offers nothing new. That is the trade the block universe makes on your behalf, without asking. And Einstein felt the cost. That is the detail history tends to leave out, and it may be the most important detail of all. To the Besso family he wrote with serene confidence. But in private conversation with the philosopher Rudolf Carnap, Einstein confessed that the problem of the now worried him seriously. The experience of the present moment, he said, means something essential to human beings, something just outside the reach of science, and the fact that physics could not capture it seemed to him a matter of painful but inevitable resignation. Hold on to that phrase, because you will not hear its like very often from the greatest physicist of the 20th century. Painful, but inevitable. He was saying, in effect, the frozen universe hurts, and I see no way out of it. Tonight is the story of a physicist who thinks there is a way out, and who believes the way out has been sitting in the strangest experiments of quantum mechanics all along, waiting for someone to read them in the right order. But before we can meet him, we owe the frozen universe its due. Einstein did not reach painful resignation carelessly, and the argument that drove him there is one of the most beautiful and airtight in all of physics. If time's passage is real, that argument has to be answered, not waved away. So let us see exactly why physics closed the future in the first place, and why for 100 years almost nobody has managed to pry it back open. The argument that froze the universe begins with a simple question. What does it mean for two things to happen at the same time? Before 1905, nobody thought that question was dangerous. Two events are simultaneous if they happen at the same moment. What could be complicated about that? The universe, everyone assumed, ticks along to a single master clock. One now, shared by everything that exists, sweeping forward together. Your now, my now, the now of a star on the far side of the galaxy. All the same now. Special relativity took that assumption apart, and it did so for a reason that sounds almost innocent. The speed of light is the same for every observer, roughly 300,000 kilometers per second, no matter how fast you are moving when you measure it. Chase a beam of light at 99% of its speed, and it still recedes from you at exactly the same rate as it does from someone standing still. That one stubborn experimental fact cannot be made to fit with a universal master clock. Something has to give, and what gives is simultaneity itself. Observers moving relative to one another genuinely disagree about which events happen at the same time, and the disagreement is not a trick of perception or a delay in the light reaching their eyes. After correcting for every signal delay, the disagreement remains. Two events that are simultaneous for you truly are not simultaneous for a traveler passing by, and both of you are right. If that sounds too abstract, there is a classic thought experiment that makes the knife visible, and it is the one Avshalom Elitzur, the physicist we will meet properly in a little while, likes to teach with. Picture a spacecraft and a tunnel that are exactly the same length when parked side by side. Now send the spacecraft through the tunnel at close to the speed of light. Relativity says that objects in motion contract along their direction of travel. This is the famous Lorentz contraction, and it is as experimentally solid as anything in physics. So from the tunnel's point of view, the speeding spacecraft is shorter than the tunnel, and for one satisfying instant you can close a door at each end and have the entire craft sealed inside. Both doors shut, ship completely contained. It happens. But now ride with the spacecraft, and the same physics runs in reverse. From the pilot's point of view, the ship is at rest, and the tunnel is what moves. So the tunnel is contracted, shorter than the ship. There is no possible moment when the whole spacecraft fits inside. Close both doors at once, and you would smash the hull. Yet no hull is smashed, and no paradox occurs, and the resolution is the whole point. The two doors did close, but not at the same time, in the pilot's frame. What the tunnel operator experienced as simultaneous, front door and rear door shutting together, the pilot experienced as a sequence. Front door closes and opens. Then, later, the rear door closes and opens. Neither observer is wrong. Same time is simply not a fact about the world. It is a fact about a point of view. Sit with what that does to the idea of now. Your now is a claim about which distant events are happening at this moment. Which heartbeat of a person in Tokyo, which flare on a star in Andromeda, shares this instant with you. But if observers in relative motion slice the universe into different sets of simultaneous events, then there is no single, correct answer to what is happening right now across the universe. A pedestrian and a cyclist passing each other on the street divide the distant cosmos into now and not yet along measurably different lines, and events that lie in the future, according to one slice, already sit in the past, according to another. The conclusion seems forced. If every slice is equally valid, then all the events on all the slices must be equally real. Past, present, and future cannot be different in kind. They must all simply exist, coordinates in a four-dimensional whole. That is the block universe, derived in a few steps from one experimental fact about light. The philosopher can resist it. The physicist, it seems, cannot. The contraction of the spacecraft is real, measured physics. And the contraction only makes sense if events across time coexist, available to be sliced one way by the tunnel and another way by the pilot. The man who gave this frozen world its geometry was Hermann Minkowski, and his story carries a sting we will feel again before tonight is over. Minkowski had been Einstein's mathematics professor in Zurich, where he famously considered the young Einstein a lazy dog who never came to class. When the lazy dog produced special relativity, Minkowski saw what its own author had not yet seen, that the theory was really a statement about geometry. In 1908, he announced it in words that still open physics textbooks. Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality, space-time. One four-dimensional fabric, in which every object is not a thing moving through the world, but a world line, a frozen thread, stretching from birth to death, every moment of it equally present. Einstein resisted at first. He grumbled that the mathematicians had made his theory incomprehensible, but when he needed the tools to build general relativity, to make gravity itself a curvature of that four-dimensional fabric, Minkowski's geometry turned out to be the only road, and Einstein adopted it completely. The student's theory and the teacher's geometry fused into the picture of reality physics still uses today. There is no record the two men ever reconciled, and there was hardly time. In January of 1909, only months after his great lecture, Minkowski died of a ruptured appendix. He was 44, and as he lay dying, by the account passed down through generations of physicists, this man, who had just handed humanity the frozen universe, said something achingly human. What a pity to die at the dawn of relativity. Keep those words somewhere safe tonight. They will come back at the very end, and when they do, I promise they will mean something different than they mean right now. Notice, though, what Minkowski's dying words accidentally reveal. A pity to die at the dawn. The sentence only makes sense if dawns are real, if something new was arriving, if the future he would miss was genuinely not yet here. The geometry he built says otherwise. In the block, the whole development of relativity, every discovery he would have loved to see, already exists, fixed at its coordinates, and his death is just the place where his world line stops. He mourned in the language of becoming, while bequeathing us the mathematics of being. That tension between what the equations say and what even their creators cannot help feeling is the crack in the door that tonight's theory will eventually push wide open. But let us be honest about the strength of the mainstream position, because tonight's optimism is worth nothing if it comes from wishful thinking. In the block picture, you are a four-dimensional object. The you of this moment is one thin slice of that object, one frame in a film strip that includes every version of you that has ever existed and ever will. Each slice carries the memories of the slices before it, which is why each one feels like the latest. The you of this evening remembers this morning and concludes that time has passed. But the you of this morning is still there, still experiencing this morning, permanently. On this view, there is no special, glowing, present version of you. There are only the slices, all equally real, each convinced it is now. The feeling of time flowing is what it is like to be a slice with memories, nothing more. And the future, in this picture, is exactly as real as a distant city. Elitzur puts it in almost those words when he describes the view he is fighting. You are not in San Francisco right now, but you would never conclude that San Francisco does not exist. It is simply somewhere else, fully real, going about its business, inaccessible to you at this moment. Relativity asks you to think of tomorrow the same way. Tomorrow is not nothing. Tomorrow is a place, as real as San Francisco, that your world line has not reached yet. Whatever you will decide next week is, on this reading, already decided, sitting at its coordinates with the patience of geography. You cannot change the future for exactly the same reason you cannot change the past. Change is something that happens in time, and time, the block says, does not happen at all. There is the proof nobody can escape, or nobody has escaped for 100 years. It rests on real experiments, real contractions, real disagreements about simultaneity that engineers must account for in the satellites above your head. Any theory that wants to give you back an open future has to walk through this argument, not around it. It has to explain why the relativity of simultaneity holds as precisely as it does, while denying the frozen conclusion everyone since Minkowski has drawn from it. That is a brutally high bar, and the first hint that the bar might be clearable comes from an unexpected place. Not from the equations of relativity at all, but from a set of stubborn facts about time that the block universe has never managed to explain. Because it turns out the frozen picture has cracks. Not cracks of logic, cracks of silence. There are things about time that it simply cannot say, and physics has been staring at them, a little uncomfortably, for more than a century. The first crack in the frozen universe is something you can see from your bed. Let a cup of coffee sit on the nightstand, and it cools. It never does the reverse. Spill milk, and it spreads and stays spread. No one has ever watched a puddle gather itself back into the glass. Physicists call this the arrow of time, the one-way direction stamped on every macroscopic process in the universe. And the reason it counts as a crack is that the fundamental laws underneath those processes do not contain it. Run the equations of motion for particles backward, and they work just as well as forward. Film two billiard balls colliding, and play the film in reverse, and nothing in the reversed film violates physics. The basic laws are almost perfectly symmetric in time, the way they are symmetric in space. Yet the world built from those laws is one-directional everywhere you look. Cups cool, milk spreads, people age. The universe, assembled entirely from time-symmetric parts, refuses to run backward. The standard name for the bookkeeping behind this is entropy. Disorder, roughly speaking, always increasing, and if you have followed this channel for a while, you know the second law of thermodynamics is a story we have circled before. But tonight the point is narrower and stranger. The arrow of the coffee cup is not alone. It has company, and the company does not obviously belong to it. Consider the second arrow. The universe is expanding. Space has been stretching for about 13.8 billion years, carrying the galaxies apart, and it shows no sign of turning around. Nothing in the equations of gravity forbids a contracting universe. The mathematics is perfectly content to run collapse instead of expansion. Yet we find ourselves in the expanding version, with the expansion itself defining a direction of time on the largest scale there is. Then a third arrow, black holes. The universe is full of regions where matter has collapsed inward, past the point of no return, but it appears to contain no white holes, the time-reverse twins that the equations permit just as readily, fountains that only expel and never swallow. Collapse happens, uncollapse does not. A fourth arrow hides in the smallest scales of all, certain particle processes involving the weak nuclear force, measured with exquisite care in neutral kaons and B mesons, are not quite symmetric under time reversal. The effect is tiny, but it is there, stitched into the behavior of matter itself. Even a few elementary particles can tell the difference between past and future. 4 arrows then: thermodynamic, cosmological, gravitational, and subatomic, all pointing the same way. And here is the crack. Nobody has ever derived one from another, let alone all of them from something deeper. The attempts are famous, and famously instructive. Stephen Hawking once argued that the thermodynamic arrow rides on the cosmological one, that disorder increases because the universe expands, giving mess ever more room to happen. It followed, he thought, that if the universe ever began to contract, the thermodynamic arrow would flip, heat would flow back into coffee cups, and inhabitants of the contracting era would remember what we call the future. It is one of those ideas that is either profound or impossible, and it turned out to be impossible, and the correction came from Hawking's own student. Raymond Laflamme, working the problem with Don Page, showed that the proposed mechanism simply fails. A contracting universe keeps right on growing messier. Hawking, to his lasting credit, conceded in print. The arrows stand unconnected to this day. 4 one-way signs in a universe whose foundations know no direction and no master arrow behind them that anyone has found. Remember that phrase, a master arrow. Before tonight is over, someone is going to propose a candidate. Meanwhile, the block universe must say something about all this, and what it says is oddly deflationary. In the block, the arrows are patterns painted on the frozen geometry. The 4-dimensional object simply happens to be arranged so that entropy is low at one end and high at the other, the way a novel happens to have its opening chapters at the front. Nothing flows. The asymmetry just sits there, an enormous unexplained fact about how the block is filled in. Perhaps that is the truth. But notice how much the picture now asks you to swallow as brute coincidence. Every arrow unexplained, and on top of them, the deepest anomaly of all, the one you are having right now. You feel time passing. The block says nothing moves, nothing happens, nothing becomes, and yet here you are, lying still in the dark, and something is undeniably going on. Moments are arriving. This one, now this one. The experience is so constant that you forget how strange it is, but the block universe has to classify it as a systematic illusion, and unlike any other illusion in science, this one has no mechanism behind it. A mirage can be traced to refraction, a dream to the sleeping brain. The felt passage of time can be traced to nothing in the physics, because the physics contains no passage for you to be detecting, even wrongly. Philosophers press this point almost immediately. Henri Bergson, the most famous philosopher in Europe in his day, stood up in Paris in 1922 and challenged Einstein face to face. Lived time, he insisted, the time of experience, of memory, of anticipation, is not captured by clock readings and coordinate slices, and a physics that leaves it out has left out something real. The historian Jimena Canales has reconstructed that confrontation in a book worth losing sleep over, and history records that Einstein won the room and the century. But it is worth remembering that Einstein himself, in that private conversation with Carnap, conceded the heart of Bergson's complaint. The now means something essential, and physics cannot touch it. Painful but inevitable resignation. Even the physicists who accepted the block could not always keep a straight face about it. Hermann Weyl, one of the great mathematicians of the 20th century and a true believer in the four-dimensional world, offered a picture that has haunted the subject ever since. The block simply exists, he said. Nothing in it changes. But consciousness crawls upward along the world line of your body, like a spark moving along a fuse, and only the point where it touches is lit up as now. It is an arresting image, and the moment you examine it, it falls apart in your hands. Because what is this crawling? Crawling is motion. Motion needs time, and Weyl's spark is supposed to be moving along the very dimension that contains all time already. To describe its progress, you would need a second clock outside the universe, and then a third for that one, forever. Roger Penrose once turned the same problem into a joke with an edge. If my consciousness has crawled a little ahead of yours, then the you I am talking to right now is a zombie, already vacated, while the real you lives slightly in my future. The joke lands because nobody, in 100 years of the block universe, has produced a workable account of why anything feels like now at all. And here and there, even at the summit of the profession, the discomfort breaks the surface. Roger Penrose has written openly that the mismatch between the block picture and conscious experience suggests we are missing something about time, not about psychology, about physics. Paul Davies devoted a book to the physics of time asymmetry and spent years, by his own account, unable to shake the feeling that the passage of time was too central to experience to be nothing at all, before making an uneasy peace with the orthodoxy. Elitzur collects these confessions almost tenderly, and he asks his audiences a question that is disarming precisely because it is not rhetorical. Am I the only one who finds this uncomfortable? Are you truly at peace with the claim that your entire life, every choice you believe you have not yet made, sits complete in a geometry, and that the feeling of making it is a trick? Most physicists, he observes, answer the discomfort with a shrug. Einstein was not happy with it, they say, but I am. Elitzur's reply is the thesis of his career, that the shrug is not an answer, and that a fact reported identically by every conscious observer in history deserves the same respect physics gives any other reproducible measurement. So this is where a century of magnificent physics has left us, and it is worth saying plainly, because the strain in the picture is the whole setup for what comes next. On one side stands the most successful theory of space and time ever constructed, insisting that the universe is a finished four-dimensional object in which nothing happens. On the other side stands everything else. 4 arrows of time the frozen picture cannot derive, and the unshakable, universal human experience of a moving present that it cannot even address, only dismiss. The equations say the river is frozen. Every fact worth calling a fact about your actual life says you can hear the water running. Most physicists live with the strain by looking away. The measurement devices work, the satellites fly, the papers get published. The problem of the now is filed under philosophy, and the file drawer is closed. But not everyone looks away. Here and there across the last century, a stubborn minority has insisted that the passage of time is not an embarrassment to be explained away, but a datum, a real feature of the world that our best theories have failed to capture, which means the theories, not the experience, are incomplete. Tonight's story belongs to the boldest current member of that minority, a physicist who not only takes the flow of time seriously, but claims that quantum mechanics, the other great pillar of modern physics, the one we have barely mentioned so far, has been quietly generating evidence for it for decades. Evidence in the form of experiments so strange that when he first proposed one of them, the journals refused to believe it. To understand why anyone should listen to such a claim, you first need to know who is making it. And his story does not begin where physicist stories are supposed to begin. It begins with a young man who never finished high school. The resume of Avshalom Elitzur is missing most of its pages. There is no high school diploma on it. There is no bachelor's degree. There is no master's degree. In the place where a scientist's long apprenticeship is supposed to be, there is essentially nothing, and then, abruptly, there is a doctorate in physics, followed by a string of papers that are cited across the foundations of quantum mechanics, followed by a thought experiment so famous that it appears in textbooks, in philosophy seminars, and in at least one Nobel-adjacent laboratory triumph. Physics is among the most credential-bound professions on Earth. It is not a field you are supposed to be able to walk into off the street. Elitzur walked in off the street. The door was opened by one of the most respected quantum physicists alive. Yakir Aharonov is a name that non-physicists rarely know, and physicists never forget. Co-discoverer of the Aharonov-Bohm effect, one of the strangest confirmed phenomena in quantum mechanics, and the inventor of a way of thinking about quantum theory that we will spend a good part of tonight inside. Aharonov encountered the young Elitzur, an autodidact with no formal standing whatsoever, and made a decision that tells you something about both men. You never finished high school, he said, in effect, but you have interesting ideas about physics. Why not do your doctorate with me? It is the kind of sentence that changes a life, and it changed this one. Elitzur became Aharonov's student, then his colleague, then his collaborator in arms, in the small, stubborn field they both love. Aharonov is now in his 90s, still active, still sharp, and Elitzur speaks of him the way you speak of a parent you are still trying to repay, with delight that his own students have become, as he puts it, Aharonov's academic grandchildren, and that great-grandchildren are on the way. Whatever else tonight's theory turns out to be, it grew inside one of the warmest mentorships in modern physics, a chain of minds handing an obsession down the generations, from a professor in his 10th decade to students not yet born when the obsession began. It is worth pausing on who Aharonov is, because his standing in physics is the collateral behind much of tonight's story. In 1959, with David Bohm, he predicted that a charged particle could be physically affected by an electromagnetic field it never touches. A particle passing through a region where the field is exactly zero would nonetheless arrive with its quantum phase shifted, simply because a field existed somewhere it never went. The prediction sounded like a violation of everything local and sensible, and it was confirmed in the laboratory, and it is now called the Aharonov-Bohm effect, and taught in every graduate quantum mechanics course on Earth. Physicists have mentioned Aharonov's name in Nobel speculation for decades. He has collected nearly every other honor the field can give, including the National Medal of Science. The point, for tonight, is his pattern. Aharonov's career is a 50-year demonstration that quantum mechanics rewards those who take its mathematics more literally than common sense allows. When a man with that record spends his later decades insisting that physics has misread the nature of time, the claim does not thereby become true, but it stops being dismissible. That obsession has a name, and the name explains almost everything about why you have probably never heard of either man in proportion to their influence. The field is called Foundations of Physics, and it asks the questions every child asks and almost no funded laboratory pursues. What is time? What is space? What is matter, actually? Why do the two great theories of reality, quantum mechanics for the small, general relativity for the large, describe worlds that cannot both be true? Modern physics funding flows, sensibly enough, toward quantum computing, communications, materials and devices. The machinery of the field rewards what can be built and shipped. The basement questions, the ones about what the building is standing on, attract few positions, less money, and a certain professional side-eye. Elitzur is frank about this with his own students. If you go into foundations, he tells them, you must be very good, you must accept a smaller salary and a slower career, and you must do it anyway, because if you truly love the deepest questions, the gains are worth the gamble. Columbus, he likes to say, never knew he had found America. He thought it was India. When you are genuinely exploring, you do not get to choose in advance what you discover. It matters, for everything that follows, that tonight's theory comes from this kind of scientist, not a celebrity chasing headlines, but a man who bet an entire unconventional life on the unfashionable conviction that the basic questions still matter. And there is a second conviction underneath, one that will quietly steer the whole rest of tonight. Elitzur believes the truth, when it finally arrives, will be simple. Physics has a patron saint for that belief, John Archibald Wheeler, the man who coined the term black hole and taught half the great physicists of the 20th century. Wheeler once predicted that when the final unifying theory is found, we will not greet it with bafflement. We will say to ourselves, how simple, how beautiful, how could we have been blind for so long? Elitzur quotes that prophecy with open longing, and he measures every candidate theory against it. He looks at the current contenders for a theory of everything, with their 10 or 11 dimensions, their curled-up hidden geometries, their landscapes of possibilities, and he simply does not believe the universe's foundation is that baroque. He may be wrong, and he says so, but his taste was formed by cases like the black hole information paradox, a puzzle we explored on a recent night, a contradiction so clean you can state it to a high school class in 5 minutes. A paradox that's simple, Elitzur argues, ought to have a resolution that is equally simple. Simple, devastating, and beautiful, because in the history of physics, that is how the great answers have tended to arrive. Faraday folding electricity and magnetism into one, Einstein folding gravity into geometry. Each revolution looked, in hindsight, less like an addition and more like a subtraction, one assumption, quietly wrong, removed. The history of unification is worth a slow breath here, because it defines the mountain Elitzur has decided to climb. Nearly 2 centuries ago, Michael Faraday demonstrated that electricity and magnetism, two phenomena as different to the eye as lightning and lodestones, were faces of a single thing, and Maxwell wrote the marriage into equations that still run your phone. A century later, physicists folded the weak nuclear force into electromagnetism as well. 3 of nature's 4 forces now speak related languages. But gravity has refused every invitation. Einstein, after geometrizing gravity in general relativity, was confident that electromagnetism would yield to the same treatment within a few years. He spent his remaining decades on that unification, and failed. And in Elitzur's blunt telling, everyone who has tried since has failed too, whatever the elegance of their mathematics. The gap between quantum mechanics and gravity, between the physics of the very small and the physics of space-time itself, remains the largest open wound in science. Any proposal about the nature of time that claims to be fundamental must eventually say something about that wound. Keep this in mind for the final hour of tonight, because Elitzur's becoming will claim, at its most ambitious, to know why the wound has refused to close. Which raises the obvious question, what assumption does Elitzur think we should remove? Where in the elaborate architecture of modern physics is the simple load-bearing error? His answer is the reason tonight's video exists. The error, he believes, is the one we spent the first hour building, the frozen future, the dismissal of time's passage as illusion. The conviction, held so widely, it barely feels like a conviction anymore, that becoming is folk psychology, and the block is fact. Everyone agrees the felt now is missing from physics. The mainstream concludes the feeling is false. Elitzur concludes the physics is incomplete. And what makes him worth an entire night of your sleep is that he does not argue the point with philosophy, he argues it with laboratories. Because here is the thing about Elitzur that changes the stakes entirely. He has been outlandishly, verifiably right before. The experiment that made his name, the one we are about to walk through slowly, in the dark, together, was rejected by journal after journal when he and Elitzur-Vaidman first proposed it. The referee's complaint was not that the paper contained an error, the complaint was that it could not possibly be true. Editors at the most prestigious journals in science looked at the claim and said, in effect, "We have never heard such nonsense." 4 rejections. And then the paper found a home, and then experimentalists built the thing, and the nonsense happened, on a laboratory table, exactly as predicted. Physicists who lived through it still describe the result with a kind of protective disbelief. Many consider it more profound than the double-slit experiment. The experiment usually crowned the central mystery of quantum mechanics. Elitzur himself, characteristically, prefers a different superlative. It is, he says, perhaps the only experiment in the whole history of physics that makes you smile. He is right. It does. And it earns the smile honestly, because what it demonstrates should not be possible in any sane universe, that an event which never happened can leave a physical mark on the world. A bomb that never exploded, changing the path of a particle that never touched it. Possibility itself, caught in the act of doing something. So here is where we stand, as the first hour of tonight closes. We have a frozen universe with cracks in it, 4 unexplained arrows, and 1 universal, undismissible feeling. We have a physicist with no diplomas, and a documented habit of being right about the impossible, who believes the cracks all trace back to a single wrong assumption about time. And we have his claim, still unproven, that quantum mechanics has been trying to tell us about becoming all along. It is time to examine the evidence. It begins with a bomb, the gentlest bomb in the history of physics, and the first object in this story to be changed by something that never occurred. Every strange thing in quantum mechanics begins with the same confession. A particle, left unobserved, does not have a single location. Send 1 photon, 1 indivisible grain of light, toward a half-silvered mirror, a beam splitter that reflects half of all light and transmits the other half, and the photon does not choose. Its wave function divides. Part of it travels the reflected path, part travels the transmitted path, and as long as nothing checks up on it, the photon is not on one path or the other in any ordinary sense. It is described, fully, correctly, and to more decimal places than any theory in science, as being in a superposition of both. The device that turns this confession into a machine is called a Mach-Zehnder interferometer, and it is worth building in your mind, because we will spend much of tonight inside it. 1 beam splitter at the entrance, dividing the photon's wave into 2 paths, 2 mirrors, steering those paths back together. A second beam splitter at the exit, where the 2 halves of the wave recombine and interfere. The 2 halves arrive with a precise phase relationship, and the interference is arranged so that toward one exit the waves reinforce, and toward the other they cancel. The result is almost theatrical. Every photon, without exception, leaves by the same exit. Call it the bright port. The other exit, the dark port, stays silent forever, because the 2 halves of the wave cancel there perfectly. 1 photon in, superposition through both arms, and interference guarantees the outcome. The dark port never, ever clicks, unless something happens along one of the paths. Block 1 arm, place any object there that could register the photon's passage, and you have destroyed the superposition. Now the wave cannot travel both ways. The interference at the exit collapses, and a photon that gets through on the open arm arrives at the second beam splitter alone, with nothing to cancel against. It flips a coin. Half the time it exits by the bright port, and half the time it exits by the dark port, the port that interference had sealed shut. Hold on to that. A click at the dark port is a message. It says the interference was broken. It says something was there, in one of the arms, capable of catching the photon, even though, as we are about to see, nothing did. In the early 1990s, Elitzur and his colleague Elitzur-Vaidman turned this arrangement into the most charming monstrosity in physics. They asked, could you use it to detect an object without any particle ever interacting with it? To make the stakes vivid, they imagined the most unforgiving object possible, a bomb, fitted with a trigger so sensitive that a single photon's touch will detonate it. Suppose you have a stockpile of these bombs. Some are live, some are duds whose triggers have failed, and a failed trigger, in their idealization, simply lets light pass as if nothing were there. You need to find the live ones. But any conventional inspection means touching the trigger with at least one photon, and a live bomb, touched, is a crater. Classically, the task is absurd. Certifying a live bomb requires interacting with it, and interacting with it destroys it. Every live bomb you identify is a live bomb you no longer have. Now run the bombs through the interferometer. Place each candidate so its trigger sits in one arm. If the bomb is a dud, light passes freely. The superposition survives. Interference does its work, and every photon exits the bright port. The dark port stays silent, and silence at the dark port tells you nothing new. But if the bomb is live, its trigger is a detector, and everything changes. The photon's wave still splits at the first beam splitter, but now the two branches lead to different fates. In the branch where the photon takes the bomb's arm, the trigger fires. In the branch where it takes the free arm, the bomb sits untouched. But the mere existence of the functioning trigger has already shattered the superposition. The photon is forced to be on one path or the other. Half the time, it is on the bomb's path, detonation. But when it takes the free path, it arrives at the exit beam splitter without its other half. Interference fails. And one time in 4, over all the runs, the photon leaves through the dark port. And that dark port click is the miracle. Follow what you now know. The photon reached a detector without touching the bomb. You know it took the free arm, because the bomb did not explode. Yet it emerged from the sealed exit, which is only possible if the interference was broken, which is only possible if the bomb's trigger works. You have certified a live bomb. The photon never touched it. Nothing touched it. The bomb sits on the table, fully armed, fully intact, measured by an event that never took place. The explosion that could have happened and did not, reached out and redirected a particle of light. Elitzur and Vaidman called it interaction-free measurement. Say it the way tonight will keep saying it. A bomb that never exploded left a mark on the world. Slow down and stand inside the apparatus for a moment, because this deserves to be felt rather than summarized. You are in a darkened laboratory, shrunk to the scale of the light itself. Ahead of you, the first beam splitter waits like a pane of half-mirrored glass, and beyond it, the two arms of the interferometer stretch away, one clean and empty, one leading past the small, patient shape of the bomb. A single photon comes down the entrance path, and you feel the strangest thing in physics happen around you. At the splitter, the photon becomes a question. Part of it flows left, part flows right. The empty arm and the bomb's arm both fill with a thin presence, like a held breath in two rooms at once. Down one branch, the trigger is grazed, and in that branch there is fire. Down the other branch, nothing is grazed and nothing burns. The branches race toward the exit. And then, in this run, the run you are watching, the world settles quietly on the second outcome. No explosion. The bomb sits inert in the gloom. The photon glides to the final beam splitter, meets no partner wave, and tips, click, into the detector that interference had welded shut. In the silence afterward, you can almost hear what has happened. The possibility of the explosion, the pure could have, reached across the apparatus and pushed a grain of light through a forbidden door. Nothing happened to the bomb, and the nothing left evidence. The referees did not believe it either. Elitzur and Vaidman's paper was rejected by 4 journals, among them by Elitzur's cheerful account, the most prestigious venues in science, with responses amounting to, "We have never heard such nonsense. An event that did not happen cannot leave a trace." What is delicious is that Elitzur holds no grudge. He says he completely understands the editors. The claim is outrageous. It merely happens to follow, line by line, from the standard formalism of quantum mechanics. No exotic assumptions, no new physics, just the mathematics everyone already accepted, pushed one honest step further than anyone had pushed it. The paper finally appeared in the journal Foundations of Physics in 1993. Within a couple of years, a team including Anton Zeilinger, later a Nobel laureate for his broader body of work on quantum experiments, had built the thing in a laboratory in Innsbruck, using interferometers and single photons, and the impossible click showed up right on schedule. Later refinements, exploiting a related phenomenon called the quantum Zeno effect, pushed the technique's efficiency far beyond the original 1 in 4, until nearly every live object in principle could be certified untouched. Interaction-free measurement is now a working laboratory tool. Roger Penrose, who devoted pages of a famous book to the bomb test, helped carry the result to the wider world, and Elitzur jokes that people who are nice to him have a way of ending up with Nobel Prizes. But tonight we care about the bomb test for a reason that goes past its cleverness, and even past its fame. Look at what it actually did to the inventory of reality. Before this experiment, physics had two comfortable categories: things that happen, which have effects, and things that do not happen, which do not. The bomb test broke the second category. An unhappened event, an explosion that remained forever potential, produced a real, recorded, physical consequence, which forces a question that sounds like philosophy and turns out to be the doorway to everything Elitzur believes. Where does an unhappened event live while it is busy having effects? What kind of existence does a possibility have in the interval before the world makes up its mind? The frozen block universe has an especially hard time here, because in the block there are no possibilities at all, only fixed events, printed on the geometry, with nothing potential anywhere. Yet here was potentiality itself, leaving fingerprints. Elitzur's answer will take the rest of tonight to unfold, but its first movement is already visible. Perhaps the quantum world is not a gallery of finished events. Perhaps it is a workshop of half-made ones, events in the process of becoming, and sometimes, as we are about to see, events in the process of unbecoming. Because the bomb test has a darker and stranger sibling, discovered by Elitzur and a younger collaborator, in which the universe does something even the bomb test never dared. It takes an event that has, in every meaningful sense, begun to happen, and erases it. The experiment that haunts Elitzur most is one he developed with the physicist Eliyahu Cohen, building on a thought experiment by their colleague Lucien Hardy, and it needs two particles instead of one. Take an electron, and take a positron, the electron's antimatter twin, identical in mass, opposite in charge. Matter and antimatter share a famous appetite. When an electron meets a positron, both vanish in a flash of gamma radiation. Annihilation. It is among the most violent and unambiguous events in physics. Two particles erased, two flashes of light, no ambiguity about whether it occurred. Now build each particle its own interferometer. The electron enters a beam splitter and divides into a superposition. Call the branches right and left. The positron enters its own splitter and divides the same way. And here is Hardy's wicked touch. In the variant Elitzur likes to teach, arrange the two devices so they overlap. One arm of the electron's interferometer crosses the arms of the positrons. If the electron takes its left path and the positron is there to meet it, they annihilate. Gamma flashes, detectors light up, both particles gone. The geometry offers two possible meeting points, one after the other, and surrounding detectors stand ready to announce any annihilation. Run the experiment many times and sort the outcomes. In some runs, there is a flash at the first crossing, annihilation, discard. In others, a flash at the second crossing, discard. But keep your eye on the runs where the detectors stay silent, where no annihilation occurs anywhere. These look like the boring runs, the ones where nothing happened. They are the most interesting runs in this entire video. Because think about what the silence has done to the electron. The positron, sitting in superposition across the electron's path, was functioning as a detector, exactly as the bomb's trigger did. Its presence asked the electron a question. Are you on the left, where we would meet, or not? When both annihilations fail to occur, the question has been answered. The electron must have gone right. Its superposition is gone, not because anything touched it, but because the meeting that could have happened did not. And this is no mere bookkeeping. Recombine the electron's paths, and the interference that a superposed electron would show is missing. Reflect the electron back the way it came with mirrors, and it does not retrace its steps the way an undisturbed wave must. Half the time it ends up somewhere a simple reversal could never send it. The electron's momentum, its actual, physical state of motion, has been changed, measurably, permanently. This is the bomb test's logic, escalated. An unhappened annihilation has reached out and shoved a particle. But now, and this is the part that Elitzur and Cohen made their own, turn and look at the positron. The electron was changed by their almost meeting. The positron was not. Recombine the positron's paths, and its interference is perfect, as if nothing had ever crossed its territory. Reverse it with mirrors, and it glides obediently back to its source, every time. Its superposition is intact. It carries no record, no trace, no scar. By every test physics can devise, the positron has never interacted with anything in its life. Let the asymmetry sink in, because it should not be possible. Two particles were set up to interact. Something clearly transpired between them. The electron came away altered, its momentum shifted by the encounter. But an interaction is supposed to be a handshake. Since Newton's third law, formalized in the 1680s, physics has treated interaction as inherently mutual. Every action met by a reaction, every push accompanied by a pushback. Nothing in classical physics, nothing in any physics before this, permits a collision with only one participant. Yet here it is, an interaction that changed one party and left the other not merely undamaged but untouched, in the strict sense that no measurement anywhere, ever, could reveal from the positron's side that anything occurred. Elitzur and Cohen gave the phenomenon a name that sounds like poetry and is meant as engineering, quantum oblivion. And notice, as Elitzur does, that it is not the physicists who forget. It is the universe. For a brief interval, the mathematics is explicit about this. The electron and positron were entangled, their fates correlated, a joint event genuinely underway. There was, in the formal description, something like a fledgling annihilation, a virtual gamma flash on its way to being real. And then the universe revised the account. The entanglement dissolved. The positron's half of the story was deleted, not ended, deleted, while the electron kept the consequences. An event began to happen, and then it unhappened, and the two participants walked away with contradictory histories, one shaped by an encounter, the other never having had it. Elitzur and Cohen went on to argue, in a paper whose title makes the ambition plain, that this become-then-unbecome capability is a master key, that a whole shelf of quantum's celebrated oddities are quantum oblivion, wearing different costumes. The bomb test itself, they showed, can be read this way. For a fleeting interval, photon and trigger begin an interaction. There is, briefly, a version of events in which the detector is firing, and then that beginning is wiped out, leaving only the photon's redirected path as the orphaned consequence. The quantum Zeno effect, in which relentless observation freezes a system's evolution. The Aharonov-Bohm effect, Aharonov's own signature discovery, in which a particle is influenced by a field it never passes through. The quantum eraser, in which recorded which path information is unrecorded and interference returns from the dead. Each, they argue, involves the same machinery underneath, events that begin and are then obliterated, leaving asymmetric fingerprints. One mechanism beneath half a dozen famous mysteries. Whether or not the full claim survives, the phenomenon at its center is standard quantum mechanics. No exotic postulates, just the formalism, read carefully. and it hands us a fact, almost too strange to hold steady in the mind. In the quantum world, the past is not entirely safe. Histories can be started and then rescinded. What has begun to happen does not always get to have happened. If the laboratory language is starting to blur in the dark, here is the whole phenomenon in a single homely image. Imagine two authors writing one scene together, trading drafts. A collision scene is begun. Both characters swerve. Both are changed. Then the editors intervene, and the scene is cut. But the cut is botched, magnificently and precisely botched, in a way only quantum mechanics permits. One character's manuscript is restored to the version before the scene, clean, as though the collision were never conceived. The other character's manuscript keeps the swerve. The published book now contains a protagonist reacting, forever, to an event the book does not contain. That is quantum oblivion, except that the book is the physical universe. The editing is done by nature itself, and the mismatched pages can be read out, run after run, in any suitably equipped laboratory on Earth. Physics has a long tradition of discovering that reality is under no obligation to match our intuitions. What it had never discovered before is that reality keeps drafts and does not always shred them cleanly. Stop and feel how directly this collides with the frozen universe we built in the first hour. The block has one unshakable principle: events simply are. Fixed, printed, eternal. Every event at its coordinates, none of them provisional, none of them subject to revision. The block has no vocabulary for an event that half exists, still less for one that existed briefly and was then erased. But the laboratory record now contains exactly such things, not as interpretation, not as philosophy, but as clicks and non-clicks, interference patterns, present and absent, momenta shifted by encounters that were cancelled after they began. Somewhere between the beam splitters, reality is doing something the frozen picture says is meaningless. It is drafting. Trying versions, keeping some, discarding others, and doing the discarding so cleanly that one of the two participants ends up in a universe where the draft never existed. Drafting, of course, is an activity. Drafts come before final copies, not in space, but in time, in some process by which the indefinite is made definite, and you can feel the question forming, the one this entire night is built to answer. What if that process is not a metaphor? What if the making definite is the fundamental thing the universe does, and what we call the flow of time is the feel of it happening? Hold the question. We are not ready for it, because the case is still missing its centerpiece. The strangenesses we have gathered so far, traces of the unhappened, histories revoked, were all discovered by reasoning forward, following the wave function from past to future, the way physics always has. But Elitzur's mentor built something better, a formalism that reads every quantum event from both ends of time at once, treating the future as an input on equal footing with the past. It sounds like mysticism. It is mathematics. Mathematics that has produced verified predictions its rivals never saw coming. And when you point it at the experiments we have just walked through, something extraordinary happens. The strangeness stops looking like chaos and starts looking like a signature. The signature of a universe in which the future is genuinely, physically, not yet decided. That formalism is the two-state vector, and it is where we go next. To see what Yakir Aharonov noticed, start with what quantum mechanics broke. Classical physics ran on two reassurances. The first was determinism. Give me the present in full detail, every position, every velocity, and the equations will hand me the future. Exactly. Fire a cannonball with known speed and angle, and its landing point is not a matter of probability, it is a matter of arithmetic. The second reassurance was time symmetry, and it came free with the first. Because the laws determine everything, you can just as well run them backward. Film the cannonball's flight, reverse the film, and the reversed flight also obeys the laws perfectly. Compute the trajectory backward from the landing point, and you recover the launch. Every time. The backward calculation is guaranteed to agree with the forward one. It adds nothing. In classical physics, the future is a redundant copy of the past. Quantum mechanics tore up both reassurances at once. Send an electron through a beam splitter, and no amount of information about its past will tell you which detector fires. The theory offers probabilities and refuses, in principle, to offer more. Determinism gone, and with it, quietly, time symmetry of the useful kind. Once the electron lands, tracing its history backward no longer yields a unique story. The one wave function, evolving forward, was the whole toolkit, and it stops short of the facts, telling you what might be measured, never what will be. Aharonov's move, first laid out in 1964, in a paper with Peter Bergman and Joel Lebowitz, and developed over the decades since into what is called the two-state vector formalism, was to ask a question of almost childish simplicity. In classical physics, the backward calculation was redundant. In quantum physics, nothing is redundant anymore. So why are we still throwing the backward calculation away? A quantum system between two measurements has a known past, the state it was prepared in, and, once the later measurement happens, a known future, the state it was found in. Standard practice uses only the first, evolving it forward and treating the outcome as a roll of the dice. Aharonov's formalism uses both. Describe the system by two wave functions, one propagating forward in time from the preparation, one propagating backward in time from the final measurement. The system, between measurements, is what the two waves say together, its present pinned between its past and its future, like a bridge anchored on both banks. Everything about that description is orthodox, except the reading of it, and the first thing to say is what the formalism is not. It is not a rival theory. Its predictions never contradict standard quantum mechanics. Every calculation, done both ways, agrees. But it is more than a paraphrase. And here, Elitzur's admiration turns evangelical, because the two-state vector formalism keeps producing correct predictions that nobody using the standard picture had thought to make. Effects sitting in plain sight of the ordinary formalism for decades, unnoticed until the two-time description made them obvious, and then, once predicted, confirmed in laboratories. Every interpretation of quantum mechanics, by definition, reproduces the theory's numbers. Only this one, Elitzur argues, has functioned as an engine of discovery. And a formalism that repeatedly sees further than its rivals, he insists, is trying to tell you something about what is actually there, not just a convenient notation, a map that keeps matching territory nobody knew existed. Here is a first taste of what the two-time view reveals. Take a particle at noon, and suppose that in the morning you measured its spin along one axis, call it the north-south axis, and got a definite answer. Suppose that in the evening you will measure its spin along the perpendicular east-west axis, and will get a definite answer there too. The uncertainty principle forbids a quantum particle from having definite values of both at once. The two measurements are incompatible, and the standard formalism, asked about noon, shrugs along the east-west axis. But the two-state vector formalism takes both anchors seriously, the morning's preparation flowing forward, the evening's result flowing backward, and concludes that at noon, this particle carried definite values of both spins, north-south, fixed by the past, east-west, fixed by the future. No law is violated, because the double assignment can only be made in retrospect. Once both anchors exist, nature keeps the uncertainty principle's operational rules intact, while the protected past turns out to be richer than the present was ever allowed to be. Between measurements, on this view, a particle leads a fuller life than quantum mechanics' public rules admit, a hidden layer of physics, laced through the gaps in the record, which weak measurement experiments in the decades since have begun to probe directly. The second revelation is bigger. Recall the puzzle Einstein could not make peace with: entanglement. Two particles born together, then separated, across a room, across a galaxy, remain correlated in a way no signal could arrange. Measure one, and the other's behavior snaps into alignment instantly, as though the news crossed the distance in no time at all. Einstein called it spooky action at a distance, and generations of experiments have confirmed that the spookiness is real. No story in which each particle carries a secret local script can reproduce what laboratories actually see. The correlations are there, and nothing traveling through space at any speed can account for them. That is the deadlock. Unless influences are permitted one more direction to travel. Watch what the two-time picture does. Measure your particle here, today, and the influence of that measurement runs backward along your particle's own history, back down its world line, at no point exceeding light speed, back to the moment the pair was created, and then forward again, up the partner's world line, to arrive at the distant laboratory. A zigzag through time. Drawn in 4 dimensions, nothing jumps across space at all. The connection between the particles is threaded entirely through their shared origin, local at every step. What looks, in the 3-dimensional present, like magic between distant strangers, is, in the 4-dimensional picture, ordinary inheritance, carried backward and forward, along paths that actually exist. The single most notorious mystery in quantum mechanics dissolves the moment you allow the future to be a real physical anchor rather than a blank. Aharonov is not even the only one to have seen it. John Cramer's transactional interpretation, proposed in the 1980s, builds every quantum event out of a handshake, an offer wave traveling forward in time, a confirmation wave traveling backward, the two meeting to make a transaction. Cramer took his inspiration from Wheeler and Feynman's absorber theory of the 1940s, which rebuilt classical electromagnetism using waves running in both temporal directions, and found the mathematics not only consistent, but elegant. Elitzur cheerfully salutes the kinship and has publicly challenged the transactional camp and every other interpretation to reproduce the specific predictions his community has derived. The two-time idea, in other words, is not one man's eccentricity. It is a recurring discovery, made independently by some of the most careful thinkers in the field, each finding that quantum mechanics becomes more local, more sensible, and more fertile the moment time is allowed to work both ways. Now gather what this means for tonight's real question, because we have just crossed a watershed. The frozen block universe of Part 2 treated the future as already existing and inert. There, the future is just more scenery, fixed events further along the 4th dimension, influencing nothing, waiting to be encountered. The two-state vector formalism treats the future as something far more interesting, an active boundary condition, a genuine physical input that reaches back and co-writes the present. And the strangenesses of the last 2 parts suddenly organize themselves around that thought. The bomb test, a future that could have contained an explosion and did not, redirecting a photon in the present. Quantum oblivion, 2 futures beginning to form, one of them cancelled, the participants left with mismatched pasts. In the standard picture, these are freaks of formalism. In the two-time picture, they are all the same phenomenon, the present being negotiated between what was and what will be. Drafts from both directions, meeting in the middle, not yet reconciled. As though the present moment were not a point on a finished line, but a seam, a place where something is still being decided. Aharonov's formalism gave that seam mathematics. What it had not yet given anyone was a reason to believe the seam is where reality is actually made, that the negotiation is not merely a clever redescription of quantum bookkeeping, but the universe's actual workshop. For that, the two-time picture needed to predict something flatly impossible, something no other reading of quantum mechanics had ever dreamed of, and something a laboratory could then go and find. In the 2010s, it did exactly that. The prediction concerned a particle hidden inside a nest of interferometers, a particle that, for a fraction of a second, in a place where no particle could be, weighed less than nothing. The apparatus at the center of this part was designed by Elitzur-Vaidman, the same Vaidman of the bomb test, and it is an interferometer with a secret inside. Begin with the familiar frame. A photon enters a beam splitter and divides. But this first splitter is deliberately lopsided. It sends 1/3 of the wave down one route and 2/3 down the other. And hidden inside that second, larger route, sits an entire additional Mach-Zehnder interferometer. A second beam splitter, dividing the wave again, 2 mirrored arms, and a recombining splitter, sealing them back together. An interferometer nested inside an interferometer. A small loop of possibility, tucked into one arm of a larger one. The kind of arrangement only a theorist who wanted to trap the quantum world into confessing something would ever build. The confession is extracted through selection. Certain detectors watch the apparatus, and you keep only the runs in which specific detectors stay silent. Runs chosen so that, by every classical standard, the photon's route is beyond dispute. The silences eliminate the inner loop entirely. Had the photon entered the nested interferometer, the outcomes you selected could not have occurred. So in the surviving runs, the story writes itself. The photon took the 1/3 route, the outer path, bypassing the nest, traveled it as a solid line from source to detector, and the inner loop stands empty, irrelevant, a room nobody entered. That is the account forward-in-time reasoning gives, and it seems airtight. Then Aharonov's formalism arrives, and does what it always does. It computes the story from both ends, forward from the source, but also backward, from the detector, where the selected runs actually terminate. And the backward story does not match. Run the wave backward from the detection, and it does not confine itself to the outer path. It flows into places the forward story swears are empty, including the arms of the nested interferometer. The forward calculation paints one set of presences, the backward calculation paints another, and the two overlap in a place that should be blank. Inside the nest, inside the loop that the photon provably never entered and provably never left, the past-going and future-going descriptions sit on top of each other, and the two-state vector formalism makes a prediction that sounds like a dare, where both waves agree something is present, physically, detectably, in the sealed room. The dare was taken. Experiments of exactly this character have been performed. One remarkable line of them, published in the journal Scientific Reports, by Japanese experimentalists, working with Elitzur's theoretical framework, with further refinements associated with the experimentalist Ryo Okamoto and Elitzur's collaborator Eliyahu Cohen. The method is delicate almost beyond belief. You cannot simply look inside the nest, because a real measurement would smash the fragile selection that creates the effect. Instead, the experimenters used the gentlest probes quantum physics allows. Weak measurements, an Aharonov invention from 1988, in which each individual run disturbs the system so slightly that it learns almost nothing, and only the accumulated statistics of thousands of post-selected runs reveal what was there. The statistics came back and said, the empty paths of the outer route are empty, and inside the sealed nest, on the path no photon entered and no photon left, there is the unmistakable physical signature of a photon having been present. A particle in a room with no doors used. Elitzur's own advice to audiences hearing this for the first time is the best summary of the scientific ethics involved. Do not believe me. Read the papers. The theory papers are published. The experimental papers are published. The predictions were made in advance, and the laboratory confirmed them. But the deepest shock is not the presence. It is the arithmetic of the presence. Follow the accounting. One photon entered the apparatus, and one photon arrived at the detector. Yet the two-time description insists there was also, briefly, a photon's worth of presence inside the sealed nest. One particle in, one particle out, and, in between, something extra that must sum away to nothing. The formalism handles this with an entry that would get a bookkeeper fired. Alongside the positive presences, it records a negative one. On one arm of the nest, the calculation returns a presence with a minus sign, the same magnitude a photon would have, pointed the wrong way. And when the books are closed, positive and negative presences cancel, one particle in, one particle out, and reality's accounts balance to the last decimal. The question is what a minus sign in front of existence could possibly mean, and Aharonov's answer is the boldest sentence in this whole story. The minus sign belongs to the mass. For a fleeting interval, in a post-selected quantum system, there was a particle whose mass, whose energy of presence, was negative. Not antimatter. A positron is ordinary positive mass matter with opposite charge. This is something else, something with no slot in the standard model of particle physics. A negaparticle, as Elitzur calls it. Presence below zero. Before you file that under theoretical hallucination, remember that physics has trusted an absurd minus sign before, and it paid off in one of the greatest predictions ever made. In 1928, Paul Dirac wrote down the equation uniting quantum mechanics with special relativity, and it kept producing solutions with the wrong sign, describing, it seemed, electrons with negative energy, which everyone knew was nonsense. Dirac's colleagues urged him to discard the solutions. Dirac declined. If the mathematics says so, he reasoned, the mathematics is telling us about something real. He predicted a new particle, the electron's positive twin, and in 1932, Carl Anderson found it in cosmic ray photographs. The positron, the first particle of antimatter ever seen, discovered because one stubborn man trusted a minus sign. Sometimes, Elitzur says, you should believe the mathematics. Nature has room in it for quantities we were sure were absurd. There is even a precedent for negative energy itself in one of the most famous results of 20th century physics. Hawking radiation, the process by which black holes slowly evaporate, is standardly described as pair creation at the horizon. From the vacuum, two partners are born, one with positive energy escaping to the stars, one with negative energy falling inward, and the black hole's mass shrinks by the debt. Physics already grants that, near a horizon, the vacuum can briefly split into more than nothing and less than nothing. The nested interferometer suggests something wilder, that this splitting is not the exclusive property of black holes. Inside an ordinary tabletop apparatus, an ordinary wave function, properly selected, briefly divides its presence into a particle and its negative twin, less than nothing conjured in a sealed room, existing just long enough to balance the books, then gone, and the negative presence pushes back on the world. This is the detail that should keep you awake, gently, tonight. In related weak measurement experiments by Vaidman and collaborators, the probes were arranged to feel the momentum the hidden presence delivers. Let the light strike a mirror, mounted so delicately that it registers each faint push, run the post-selected ensemble, and read the accumulated force. A photon that lands on a mirror pushes it. This is as old as the physics of light. In the selected runs, at the anomalous location, the mirror moved the wrong way, pulled, where every photon in history has pushed. The apparatus behaved exactly as it would if what struck the mirror carried negative mass, the recoil of less than nothing. Stand inside the nest one last time before we leave it, because nothing in tonight's story is stranger, and you have earned the view. You are in the sealed loop, the room with no used doors. Forward in time, from the source, a thin tide of possibility washes toward you and stops short, forbidden by the selections, unable to enter. Backward in time, from the detector where this run will end, another tide flows the other way, into the loop, filling it, insisting that the story of this photon passes through here. You stand where the tides overlap, and in the overlap something condenses, a presence, real enough to lean on a mirror, wrong enough to lean the wrong way. It has the shape of a photon and the weight of a hole in the world. It exists the way an overdraft exists, a genuine amount, pointed downward. For a few nanoseconds the room holds it, matter below zero, summoned by the meeting of a past that came forward and a future that came back. Then the run completes, the selection closes, the books balance, and the room is empty again, was always empty, the forward story will insist. The mirror's tremble says otherwise. Step back now and look at the whole exhibit we have assembled, because the parade of impossibilities has been quietly converging on a single suspicion. A trace left by an unhappened explosion, a history begun and revoked, one participant scarred, the other wiped clean. A present pinned between two waves, one arriving from the past and one from the future. And now, presence itself, briefly running negative, in a chamber that both exists and does not exist, depending on which direction of time is telling the story. Every one of these is orthodox quantum mechanics, and every one of them is a catastrophe for the picture of reality as a finished block of fixed events. Whatever reality is doing between preparation and measurement, it is not sitting still. It is trying, revising, borrowing, cancelling, behaving less like a completed sculpture and more like wet clay under working hands. The question Elitzur asks, the question that turns this whole cabinet of curiosities into a theory, is the simplest one imaginable. What if we take that appearance at face value? What if the universe genuinely is unfinished, and the strangeness of the quantum is what unfinished reality looks like, up close? To go there, he must do the one thing physics has forbidden for a century. He must say the flow of time is real. That is the assumption nobody dared make. It is time to make it. Let us step back and put the pieces together, slowly, because we have covered an enormous amount of ground tonight, and the next step only works if the ground is solid under us. We began with a letter, Einstein consoling a grieving family with the doctrine that past, present, and future are an illusion. And we saw why physics believes it. The relativity of simultaneity, demonstrated by the spacecraft in the tunnel, seems to force all moments to coexist in a frozen four-dimensional block where the future is exactly as real as San Francisco. Then we found the cracks, 4 arrows of time, cooling coffee, expanding space, black holes without white holes, particles that tell past from future, all pointing one way, none of them derived from anything deeper, all of them decorations the frozen picture carries, but cannot explain. And beneath the arrows, the crack that never closes, the felt passage of time, universal, undismissible, and absent from the equations, a problem so sharp that Einstein privately called his own resignation to it painful. Then we met the witnesses. A bomb certified live by an explosion that never occurred. An electron rewritten by an encounter its partner never experienced. History drafted, then partially erased. A formalism that reads the present from both ends of time and keeps discovering physics nobody else saw. And finally a sealed chamber in which past-going and future-going descriptions overlap, and something with negative mass briefly pushes back on the world. That is the evidence. All of it published, most of it laboratory tested, none of it fringe. Now comes the turn, and I want you to see the shape of it before we take it. Every mystery in that list is a mystery because of one shared assumption, an assumption so old and so foundational that physics has stopped noticing it is there. The assumption is that reality is complete, that every event, past and future, is already fixed, that the inventory of the world is finished, that nothing is ever genuinely added. Grant that assumption, and everything we have seen tonight becomes a paradox. Unhappened events cannot leave traces, because there is no such thing as unhappened. Histories cannot be revised, because history is printed. The future cannot co-write the present, because the future is just more printed pages, and presence below zero is an absurdity of bookkeeping. Physics has spent 40 years inventing brilliant, tortured workarounds to keep these results inside a finished universe. Elitzur proposes something almost insultingly simpler. Drop the assumption. Say it plainly, the way he does. Becoming is real. Time genuinely passes. Events are not eternal coordinates. They are created, one after another, in causal order, and once created, they harden into the permanent past. The now is not a spotlight crawling along a finished line. The now is the front line of creation, the exact place where reality is being added to reality. And the future, this is the sentence on which everything tonight turns. The future does not exist, not as fixed events, not as unknown but waiting facts, not as anything. Tomorrow is not a distant city. Hold the phrase from part 2 up to the light and break it. The future is not San Francisco. There is no there, not yet. What lies ahead of the now is not darkness, which would at least be something. It is the not yet, absence itself, waiting to be replaced, moment by moment, with world. Understand exactly how much defiance is packed into that paragraph. Physics does not merely doubt the passage of time. It has spent a century arguing the very idea is incoherent. The standard objection goes like this. Motion means changing position with respect to time. So how could time itself move? At what rate? 1 second per second? The question is supposed to expose the absurdity. If time flows, it must flow with respect to some second, higher time, and that one with respect to a third, and the tower never ends. Whale's crawling consciousness died on exactly this hill in part 3. Elitzur's response is not to solve the regress, but to refuse its premise. The passage of time, he suggests, is not a motion within some larger container. It is the fundamental activity of reality, the thing in terms of which all motion, all change, and all containers get defined. Every chain of explanation ends somewhere. Every physics has its bedrock that explains everything else and is explained by nothing. The block universe chooses static existence as bedrock, and then cannot build the feeling of now out of it. Elitzur chooses becoming as bedrock, and look what the choice buys. The felt passage of time stops being the illusion every mind mysteriously shares, and becomes the single most accurate observation you have ever made. You feel time passing because it does. Where the frozen picture must call the deepest experience of every conscious being a systematic error, with no mechanism, becoming simply says, that is the universe you feel, being built. But be careful here, because it would be easy to hear all this as a door swinging open to time travel and messages from tomorrow, and the proposal says nearly the opposite. Becoming is strict about the past. Once the now moves on, what it has created is finished. The past is not a place you could go, because going somewhere is something that happens at the front line, in the present, where all happening lives. In a block universe, ironically, the past at least exists as a destination. In becoming, yesterday is complete and closed, and there is no vehicle, even in principle, that reaches it. The physicist Lee Smolin has a phrase Elitzur is happy to borrow. The block universe is right about the past. Fixed, real, permanent. Everything the block claims about all of time is true of the part that has already been made. What about the quantum retroactions we spent 3 parts marveling at? The futures reaching back, the histories revised. They are real. But look at their fine print. Everyone lives inside the quantum interval, the window between preparation and final measurement, while the wave function is still open and the universe has not yet committed. Quantum oblivion revises drafts, never publications. The 2-state vector's backward wave runs from a measurement that has happened to a preparation that has happened. Nothing signals from the unmade future into the settled past. And no experiment in this entire evening lets anyone send so much as 1 bit backward to change a fixed fact. The becoming picture absorbs the strangeness precisely by locating it, the seam, the unfinished edge, the brief, flickering zone where events are still drafts, the only place in the universe where revision is possible, because it is the only place where anything is still being written. And notice what that implies, because it is the quiet master stroke of the whole proposal. Quantum mechanics and the flow of time, physics' two great embarrassments, each inexplicable on its own, turn out to be each other's explanation. Quantum indefiniteness is what the leading edge of creation looks like. The flow of time is what quantum indefiniteness resolving feels like. Two mysteries, one seam. If you find yourself pushing back right now, you are in excellent company, and the strongest objection is one we built ourselves 2 hours ago with a spacecraft and a tunnel. The relativity of simultaneity showed that observers slice the universe into different nows, and we concluded that no single now can be real, which seemed to freeze everything. A theory of becoming must answer Einstein here, or die on the spot, and Elitzur knows it better than anyone. His entire teaching career runs through that argument. Notice first a logical subtlety. Relativity shows that physics has gotten along without a privileged universal now. It does not show there is none. The slices are all consistent with the equations, precisely because the equations are silent about which moment is being created. Silence is not denial. A becoming universe must simply be one in which the front line of creation does not announce itself in the mathematics we currently have, and, Elitzur suspects, the front line may be stranger than a tidy universal instant, locally textured, rippled by gravity and quantum entanglement in ways his proposal is only beginning to sketch. Is that a complete answer? No, and he does not pretend otherwise. Do I have a theory? He asks himself out loud, and answers, if I had one, I would be dancing on my way to Stockholm. Not yet. What he has is a model growing flesh and bones, a direction, backed by the strangest verified experiments in quantum mechanics, aimed at the oldest unsolved problem in physics. And the direction now faces its real test. Because if becoming is bedrock, if the future is truly nothing, and the now is truly the edge of creation, then an enormous question opens beneath everything we have said, one that will carry us to the strangest and most beautiful idea of the entire night. If events are created at the now, what about the stage they are created on? What about space itself and time itself? Do they extend out past the front line, empty scaffolding waiting for events to arrive? Or is the scaffolding created too? Elitzur's answer is the boldest thing a physicist has proposed about time in a century. There is no scaffolding. Beyond the now, there is no empty future waiting to be filled. No space, no time, nothing at all. And the universe you are lying in is not sitting inside time. It is making time, the way a fire makes light. That idea, the universe still being born, is where we go now. The step from real time to created space-time runs through an old and honorable principle associated with the physicist and philosopher Ernst Mach, the thinker whose writings, Einstein always said, prepared the ground for relativity itself. Mach's principle, in the form Elitzur leans on, says this: space and time are not things. They are not containers, not stages, not pre-existing emptiness waiting for a show. Space is nothing but the web of relations between events. Distances mean the intervals between happenings, durations mean the separations between changes, and where there are no events, talk of space and time is talk about nothing at all. Einstein absorbed this deeply. General relativity made geometry itself dynamical, something shaped by matter rather than a fixed backdrop behind it. But Elitzur pushes the principle one step further than relativity ever did, and the step is disarmingly simple. If space and time exist only where events do, and if, as becoming insists, no events exist beyond the now, then nothing exists beyond the now. Not fixed future events, as the block would have it, but also not empty future space, waiting, not unticked future time, stretching ahead like an unused road. Beyond the leading edge of creation there is no ahead. The future, in Elitzur's phrase, and it may be the most quietly radical sentence a physicist has uttered about time in our lifetime, is the nowhere and the no-when. There is nothing there, not even space-time. Every mind rebels at this in the same way, so let us treat the rebellion with respect. You are, right now, involuntarily picturing it, the universe's history as a growing block, and ahead of the growth, some kind of dark void into which it grows. Empty blackness, waiting. But look closely at that picture, and it dismantles itself. The void you are imagining has extension, has location, has a when. It is space-time by another name, smuggled back in by an imagination that has never once had to picture genuine nothing. Even Elitzur laughs at the impossibility. Presenting the idea in lectures, he must draw something on the slide. And the philosopher Immanuel Kant explained the trap 2.5 centuries ago. Space and time are the built-in canvas of all human thought, and asking a human mind to picture their absence is asking a painter to paint the absence of canvas. This is why physicists have a ready answer when a student asks what lies outside the universe. The question is malformed. Outside assumes space, and space is part of the universe, so there is no outside. And now watch Elitzur's move, because the whole vision pivots on it. Take that answer, the one physics already accepts about the edge of space, and apply it to the edge of time. What was there before the Big Bang? Malformed question, says standard cosmology. Time began at the bang. There is no before. Nearly every physicist alive endorses that sentence. Elitzur simply asks if you can accept that time itself once had an edge, that before the beginning is not a dark waiting room, but a non-place where the very word before loses meaning, then why do you refuse the same honesty about after the now? The future is not a dark waiting room either. It is the same non-place, the nowhere, the no-when. And with that, the Big Bang stops being history. This is the reframe that, once you see it, is difficult to unsee. Standard cosmology describes the bang as the event in which space and time themselves came into existence, not an explosion in a pre-existing emptiness, but the ignition of extension and duration as such, followed by expansion, more space arriving between the galaxies, the universe growing not into anything, but simply growing. Every part of that description is orthodox. Elitzur adds one clause, and the clause changes everything. The universe is expanding in time as well. Just as new space keeps arriving between the galaxies, new time keeps arriving at the now. Each moment a fresh layer of existence deposited on the growing block of the past. Each now the newest surface of a universe that has never stopped being created. The Big Bang in this picture was not the moment creation happened. It was the moment creation started. It is happening now. The leading edge of the primordial fire, the very frontier where nothing is being turned into something, is not 14 billion years behind you in some unreachable past. It is here. It is this moment. You have spent your whole life at ground zero of the Big Bang, because ground zero is the now, and the now is where the universe is still detonating, gently, continuously, at the rate of 1 moment per moment. Notice, too, that this move quietly disarms the oldest objection to the passage of time, the infinite tower of clocks we met earlier tonight. The regress argument assumed that if time flows, its flow must be measured against some higher time, and that one against a higher one still, forever. But watch how standard cosmology already escapes an identical trap. When physicists say time was created at the Big Bang, nobody demands to know what schedule the creation kept, or how long the creating took. The questions dissolve, because creation of time is not a process inside time. Elitzur claims exactly the same immunity for the now. The arrival of each new moment is not a motion through some meta-time. It is the same kind of event as the bang itself. the coming into being of time, which needs no clock behind it, for the same reason the bang needed no calendar before it. You may find that answer profound, or you may find it slippery, and honest physicists have said both. But it is not obviously wrong, and for an idea dismissed as incoherent for a century, not obviously wrong is the sound of a door unlocking. Lie still and let yourself stand there for a minute, at the actual edge. Face forward, toward what we have all been taught to call the future. There is no road ahead. There is not even darkness ahead. Because darkness is something, a volume, a place, a when. And ahead of you, there is no volume, no place, no when. The universe does not end at a wall. A wall would need somewhere to stand. It ends the way a song ends at its newest note, not against a barrier, but simply, so far. And yet the edge is not static. Something is happening, the only utterly fundamental happening there is. Beneath your attention, this moment is arriving, a complete new cross-section of reality. Every particle, every field, every star, every sleeping town, you in your bed, being added to the sum of what exists. And now it has hardened, and is past, and cannot be revised. And now, again, a new layer, arriving, and again. You are not moving through time tonight. There is no through, no corridor, no track laid ahead. Time is being made, and you are made freshly with it, at the crest of a wave that began with the Big Bang and has never once broken. A wave whose leading edge is the exact sensation you call now. Listen to the quiet of your room. That quiet is the sound of the newest layer of the universe being laid down, with you inside it. Return, with that image, to the deepest crack we found in the frozen picture, the arrows of time, the 4 unexplained one-way signs, because becoming finally offers them what a century of physics has not, a common source. Recall the puzzle in its purest form. The fundamental laws barely distinguish past from future, yet coffee cools, the cosmos expands, collapse never reverses, and even certain particles keep a faint arrow in their behavior. 4 asymmetries, unconnected, underived. The block universe must accept all 4 as brute facts, painted on the geometry. But if becoming is real, the asymmetry of time is not a decoration on reality. It is the engine of reality. Events are created and then fixed. The process runs one way, because creation is one way. What is made joins the past, and what is not yet made does not exist to constrain anything. On this view, there is a master asymmetry after all, becoming itself, and the thermodynamic, cosmological, gravitational, and subatomic arrows would all be its descendants. 4 shadows, cast by the single fact that the universe is built front to back. Can Elitzur derive them from it? No, and he says so with disarming flatness. He does not yet know how to extract the second law of thermodynamics, or the expansion, or the particle asymmetries from the postulate of becoming. That derivation is the research program, not the result. But note what honest currency the proposal already trades in. It is the only framework on tonight's table for which the arrows are not embarrassments to be explained away, but exactly what you would expect. A universe under construction should show a grain, the way wood remembers the direction it grew. There remains one more piece, and it is the one that turns a philosophy of time into a candidate physics of everything. So far, becoming has told us when reality is made, at the now. It has told us what lies beyond the edge, nothing. But it has not told us how the making works, what actually happens at the seam where nothing becomes something. And here Elitzur reaches back to everything we built in the middle of tonight, the drafts and revisions, the waves meeting from both directions, the presences that flicker positive and negative before the books are balanced, and proposes the connection that makes this whole night one single story. The machinery at the seam is quantum mechanics. The strangeness we toured in those laboratories is not a collection of anomalies. It is the construction process itself, photographed mid-act. And if that is true, then quantum measurement, the most argued about event in all of physics, is about to receive the strangest job description it has ever been given. Not discovering reality and not disturbing it, building it, including, as we are about to see, building the empty space around every particle and the entire past history of anything sealed away from the world. The theory is nearly assembled. What remains is to watch it work. Begin with the moment quantum mechanics has never been able to explain to anyone's satisfaction: the collapse. A particle's wave function spreads through an apparatus, through both arms of an interferometer, through 1,000 possible positions, and then a measurement happens, and the spread is gone. One position, one outcome, one fact. Every interpretation of quantum mechanics is, at bottom, a different way of coping with that transition. And we have toured the options on other nights: worlds that branch, waves that guide, information that updates. Elitzur proposes a reading that none of the textbooks contain. When the wave function collapses, he suggests, it does not merely produce the particle's position, it produces the space around the particle, the empty places, the positions where the particle could have been found and was not, are not pre-existing rooms that turned out to be unoccupied. They are created empty, in the same act that creates the particle's location. Collapse, in other words, is not an event in space. Space is a product of the event. Hear how strange and how strangely sensible that is. The standard picture has always carried an unexamined assumption that space sits there first, a fixed grid of positions, and the wave function then spreads across it, like spilled water across a tiled floor, until measurement mops it up into one tile. Elitzur inverts the dependency. At the leading edge of becoming, there is no floor yet. The wave function is not spreading through the not yet created. The wave function is the not yet created, reality's working draft of the next moment, a sheaf of possibilities, none of which has been built. Measurement is the construction event, the interaction at which one possibility is made actual, and the alternatives are made empty, stamped into the new layer of the world as genuine vacancy, real empty space, where something could have been, and now, permanently, was not. The vacancies matter. They are not leftover stage, they are manufactured absence. And the bomb test already showed you manufactured absence doing physical work, when a photon's forbidden exit was opened by an explosion that got written into history only as a could have. On this reading, every quantum measurement performs the same double act. It writes one small something and a surrounding halo of nothing into the permanent past, and the two are equally real products of the writing. Now take this construction picture and hand it the most famous prisoner in physics, Schrödinger's cat. A cat sealed in a box with a quantum trigger, superposed, says the standard story, between alive and dead until observation decides. Elitzur savors a question one of his students once put to him about that story, a question sharp enough to cut it open. "Fine," she said, "but leave the box closed for 3 days. When you finally open it, you never find a cat frozen at the moment of sealing. You find a cat that has been living for 3 days, hungry, cross, the box in a state a live cat makes it, or a cat that has been dead for 3 days, in a state no fresher death could counterfeit. Either way, the box contains a history, 3 days of definite events, meals missed, hours passed, that supposedly did not happen while the box was sealed, because nothing in a superposition happens definitely. So when did those 3 days occur? The standard formalism mumbles here. Elitzur's answer is vertiginous and perfectly consistent with everything tonight has built. While the box was sealed, truly sealed, no light, no heat, no whisper of interaction leaking out, becoming passed it by, the now swept forward and built the world's new layers around the box, leaving, in Elitzur's image, an unfilled corridor, a region where no events were created because no interactions selected any. And when the box is opened, becoming floods in and builds the corridor's contents, all of it, the entire 3 days, the missed meals, and the slow hours, created in the instant of opening, as finished past. Opening the box does not reveal the cat's history. It commissions it. If that sounds like a step too far even for tonight, be reassured that its logic has a respectable ancestor, one this channel has visited before. John Wheeler's delayed choice experiment showed that how you measure a photon arriving now determines the kind of path it took, wave-like through both slits or particle-like through one, even when the choice of measurement is made long after the journey. In Wheeler's grandest version, light from a distant quasar, bent around an intervening galaxy across billions of years, has its ancient itinerary settled by a decision an astronomer makes tonight. Physicists have made their peace with delayed choice by insisting no signal changes the past. Elitzur's becoming gives it a home instead of a truce. The photon's distant past was never built, because nothing had yet forced its construction. The measurement tonight is the event that finally lays down that stretch of history, a corridor, billions of years long, filled in at the moment of interaction. The past, in becoming, is absolutely fixed once written, but it is written only when the seam of creation actually touches it. Some of the universe's past, right now, is still blank paper. And with that, Elitzur is ready to answer the question that opened modern physics, and to aim, with open-eyed audacity, at the prize Einstein died without winning. Why is the speed of light the same for every observer? Relativity postulates it and never explains it. The invariance of light speed is the brute axiom from which the spacecraft, the tunnel, and the whole frozen block were derived. Elitzur notices what the axiom quietly says. Light speed is invariant, and so, measurements confirm, is the speed of gravitational waves. What do light and gravity have in common? They are the universe's carriers of connection. Photons are what atoms trade to hold a ruler stiff and a clock ticking. When you press on a table, the resistance is electromagnetic messaging between its atoms and yours. Gravitational influence is what binds planets to stars and galaxies together. These are not just phenomena in the universe. They are the threads the universe's relational fabric is woven from. Now put that beside the construction picture. If space and time are created by quantum interactions, if distances and durations exist only as fast as interactions weave them, then the carriers of interaction are not traveling through space-time at some speed. Their exchange is what generates space-time, and what we call the speed of light is really the loom rate of reality, the fixed pace at which causal connection knits new world. Of course, every observer measures it the same. It is not a speed within the fabric, but the making of the fabric itself, the one process every ruler and every clock is downstream of. The invariance of light speed stops being an axiom and becomes a consequence. And then, the reach for unification. Einstein spent his last 30 years trying to do for electromagnetism what he had done for gravity. Turn it into geometry. Fold the electric and magnetic forces into the curvature of space-time. He failed. Everyone since has failed. The two great forces of attraction in daily life remain described in languages that refuse to merge. Elitzur suggests the failure has a diagnosis. Everyone has been trying to reduce forces to a space-time assumed to exist already. Reverse it. If interactions precede space-time, if geometry is deposited by the exchange of photons and gravitons at the seam, then attraction and repulsion are not forces acting across space. They are patterns in how space gets made. Where interactions deposit less distance between two bodies, moment by moment, we say they attract. Where more, they repel. The relative positions of things being continuously relayed at the now. The way general relativity already lets mass tell space-time how to curve. Extended now to charge as well. Could gravitational and electromagnetic attraction be siblings at the level of the loom? Two rules in the grammar of creation. Here Elitzur is at his most speculative, and tonight will not pretend otherwise. This is a sketch, offered without mathematics, the kind of idea that is either a foundation or a mirage, with the sorting still to be done. He says as much himself, and the honesty is part of why he has earned this long night. No dancing toward Stockholm, a model growing flesh and bones, equations still to come, and cosmology's own frontier, where theorists already speak of what preceded the bang in frameworks beyond space and time, invited, explicitly, to come test the water. So stand back, one last time, and see the whole proposal assembled, because scattered across 3 hours it has quietly become a single machine, and you should get one clear look at it running. At the base, becoming time's passage as bedrock, the one assumption changed. Above it, the future as genuine nothing, no events, and by Mach's principle, no stage either, the nowhere and the no-when. At the seam, quantum mechanics as the construction process, wave functions as drafts of the next moment, the two-time formalisms forward and backward waves as the negotiation by which drafts are reconciled, collapse as the act of construction that writes both particle and vacancy into the permanent past, oblivion as drafts discarded, the negaparticles borrowed negative presence as scaffolding, glimpsed for a nanosecond before the books close. Beneath the whole structure, the arrows of time as the grain of one-way construction, and at the crown, the boldest promises, light speed as the loom rate of connection, and force itself as the geometry of fresh creation. One assumption exchanged, the finished universe for a universe in progress, and mystery after mystery lines up like iron filings in a field. It is not a theory yet. It is something rarer, a direction with evidence, and it leaves exactly one question standing, the question this entire night has been walking toward, holding its answer back, the way the now holds back the future. Why call this, of all things, the most optimistic theory in modern physics? It is time to answer that, and to bring the night home. The theory has a name now, and you have watched every piece of it earn its place, becoming. The claim that time's passage is real and fundamental, that the now is the leading edge of a universe still under construction, that the future is the nowhere and the no-when, not written, not stored, not waiting, but genuinely nothing at all until the seam of creation makes it something. And the reason I have called it the most optimistic theory in modern physics has been hiding in plain sight all night, inside the one sentence that sounds, at first hearing, like a loss. The future does not exist. Sit with that sentence one more time, because tonight it means the opposite of what it seems to mean. If the future does not exist, then the future is not fixed. Nothing about tomorrow is already true. There is no four-dimensional block in which your next year sits finished, no coordinates where your hardest day and your best day wait with the patience of geography. No script, your life is merely performing. The block universe told you, with all the authority of Einstein's own pen, that your future was as real as San Francisco, a settled place your world line would visit on schedule. Becoming answers. The future is not San Francisco. It is not anywhere. It has not been built, and you are one of the things building it. Measure the distance the night has carried us by returning to where it began, that desk in Princeton, the spring of 1955, an old man consoling a grieving family with the doctrine of the frozen block. For us believing physicists, Einstein wrote, the distinction between past, present, and future is only an illusion, however persistent. All night, that sentence has stood as the summit of the mountain we were climbing. Now stand on the far side of it and read it again, because becoming does something almost mischievous to its final two words. However persistent. Einstein chose them as a concession. The illusion is stubborn, he meant. Though illusion it remains. But if Elitzur is right, the persistence was never stubbornness, it was accuracy. The felt arrival of each new moment persists in every mind that has ever existed, because it is the one report every mind files directly from the construction line of reality. The illusion, on this reading, ran the other way. the frozen block, the magnificent, airtight, comfortless geometry, was the artifact. A still photograph, mistaken for the world, because the mathematics that took the photograph had no shutter for motion. And the consolation Einstein reached for at that desk comes back transformed rather than destroyed. He told Besso's family that their father was not truly lost, because the past never stops existing. Becoming keeps that half whole. The past is real, permanent, safe. Every moment Besso lived remains woven into the fabric of what has been built, and nothing that has ever happened can be unhappened. What becoming declines to freeze is only the part that was never frozen, the part still to come. Be clear one final time about what tonight has been, because optimism, earned dishonestly, would be worth nothing in the dark. Becoming is not established physics. It is a proposal, presented by Elitzur in raw form, without mathematics, a research program rather than a result, and he is the first to say so. The experiments are real, the bomb certified by the explosion that never came, the electron rewritten by an encounter its partner never kept, the two-time formalism's verified surprises, the sealed chamber where presence briefly ran below zero. Those stand in the published record, regardless of what becomes of the theory. What remains unproven is the grand reading, that these are photographs of creation in progress. It may fall. Physics is a hard judge, and most beautiful ideas die young. But this one comes from a man whose impossible ideas have a habit of surviving the judge. And it would hardly be the first time the century turned on someone trusting a thought everyone else had filed under nonsense. A bomb that never exploded left a mark on the world. Tonight, at minimum, an idea that may never be completed has done the same, because whatever the final verdict, the question it reopens can no longer be politely ignored. The passage of time is either the greatest illusion in nature or its deepest law, and for the first time in a long while, serious physics is being done on the second possibility. And so, at last, to the small hours of this particular night, and to you, every night of your life, you have fallen asleep inside somebody's picture of time. Fall asleep inside the frozen one, and tonight is a coordinate you were always going to occupy, tomorrow a page already printed, and rest just the interval between two fixed marks. Fall asleep inside becoming, and the room around you is the newest thing in existence, the freshest layer of a 14 billion year construction, still warm from the making. The quiet you can hear is the seam at work. The moment arriving now was not merely unknown a second ago. It was nothing a second ago. And now it is the world, with you in it. And tomorrow, whatever it brings, is not lying in wait. It does not exist. It will be built at the only construction site there has ever been, the now, partly out of materials you choose. That is what the mathematics of the block could never see, and what the strangest experiments in quantum physics keep hinting at. The universe is not finished, and neither, therefore, are you. Whatever is unresolved in your life tonight is unresolved in the deepest physical sense, not suspended, not scheduled, but genuinely open, waiting on a creation that has not happened yet and cannot happen without you. And notice what this does to the oldest anxiety of all, the one the block universe answered with cold comfort. In the frozen picture, free will was not so much denied as declared meaningless. Your deliberations exist in the block, and their outcomes exist in the block, and the feeling of weighing a decision is just another fixed event, no more consequential than a photograph of a scale. Becoming does not prove your will is free. No physics tonight proves that, and honesty forbids pretending otherwise. But it restores the one precondition without which the question cannot even breathe, an open future. In a universe under construction, your deliberation happens at the seam, before the outcome exists, and whatever choosing turns out to be, it happens where things are still being made, not in the archive of things finished. The difference between those two universes cannot be measured in any laboratory tonight. It can be measured in what it feels like to wake up tomorrow. Remember Minkowski, dying in the first winter of the frozen century he had drawn, whispering that it was a pity to die at the dawn of relativity. All night his words have waited for their answer, and it turns out Elitzur has already written it, a blessing he offers at the close of his own telling of these ideas, and the only possible last word for a universe that is still being born. In a block universe, there are no dawns, there is only the block, and every sunrise is already filed. But if becoming is true, then dawn is not a metaphor. Dawn is the permanent condition of reality, the front line of creation, breaking continuously, everywhere, forever. May it always be a pity to die, Elitzur says, and may there always be a new dawn waiting. That is the most optimistic theory in modern physics. Not a promise that tomorrow will be kind, but a demonstration, argued from bombs that never exploded and particles that weighed less than nothing, that tomorrow, kind or not, is truly yours to make, because it does not exist until you and the universe make it together. Thank you for spending this night with me at the edge of the now, where the universe is still being built. If explorations like this one are how you like to fall asleep, a quiet like or a subscribe would mean a great deal. It is a small thing for you, and it genuinely helps me keep making these long nights. And remember, the next time you feel a moment arrive, that soft click of now becoming now, you may be feeling the oldest process in existence, the universe adding one more layer, with you inside it. Good night, and may you never look at tomorrow the same way again.